So we've been talking about Pythagorean theorem for the past couple videos, the past couple days. Now we're going to do a foldable over what the Pythagorean theorem really is. So in your packet, you have this paper. We're going to take this paper, we're going to make a foldable. So this is the front. You're going to flip it over. You're going to fold it into threes. So this should get folded over like this, and this gets folded on top. So kind of like you're making a brochure, something like this, okay? So now you have this on the front, you can open this up, you have vocabulary, you have steps, and then we have some examples on the inside, okay? So before we get into all that, we're gonna talk about the right triangle first. Okay, so we know from previous lessons that this is a right angle. Okay, we have a right angle, so that makes this triangle a right triangle. We have this side here, which is a leg, and we call that leg A. Then we have this side here, which is also a leg. We can call that leg B. Now, it really doesn't matter which of these legs gets A or B, because they're both legs. Okay, so I could have given this one A and this one B. But as long as we identify these sides as legs and that a leg either gets an A or a B, you're okay. The longest side of our triangle, or the side opposite of our right angle, the slant, this is our hypotenuse. Okay? That's your longest side. And we use the variable c to represent this side right here, okay? The actual Pythagorean theorem is this right here, a squared plus b squared equals c squared. In the video before this, we talked about how this is using models. The area of the square connected to leg A plus the area of the square connected to leg B is equal to the area of the square connected to leg C, or I'm sorry, the hypotenuse C. Okay, so now we're going to open this up and we're going to look at some vocabulary. So the first one, a right triangle is a triangle with a right angle. Should be review. The hypotenuse is the longest side of a right triangle. Your legs are the two sides of a right triangle that meet at the right angle. And then the last one, Pythagorean triplets are a set of integers that fit the rule a squared plus b squared equals c squared. For example, this right here, we have multiples of 3, 4, and 5. So some other examples would be like the side lengths of 6 and 8, because I would multiply both of these by 2. So that means my longest side would be 5 times 2, which is 10. They are multiples of 3, 4, and 5. And then you could keep going. I mean, another example would be like 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. All right, so let's move on to the steps. Okay, so right here, steps when I'm missing the hypotenuse, when I'm missing this long side right here, okay? We are gonna follow these steps here. I'm gonna do leg squared plus leg squared equals hypotenuse squared, which is the same thing as a squared plus b squared equals c squared, right? I'm gonna label my parts. I have A, B, and C, so I know which one goes to which. I plug in the numbers for my value. So I know that A is 4, so I plugged in 4 for A. I know that my B is 3, so I plugged in 3 for B. I don't know my C, so I'm going to leave that there. Then I come over here and I simplify. So 4 squared is equal to 16. 3 squared is equal to 9. I still don't know C, so I leave it as it is. So now I have 16 plus 9 equals C squared. Then I need to add my legs together. This is very important. We're going to add our legs together. So 16 plus 9 is 25. So 25 equals C squared. Then I want to get C by itself. I want to figure out the value of C. So in order for me to cancel out this squared right here, I need to do the square root. So if I take the square root of both sides like I did here, because if I do it to one side, I need to do it to both. This right here, the square root of C squared, cancels out the squared, and I'm left with C all by itself. Then I have the square root of 25, which is 5. So C equals 25. I'm sorry, so C equals 5, not 25. So I have a 3, 4, 5 right triangle. Okay, so here is a tip to help you remember. Whenever we are missing the hypotenuse, whenever we're missing C, we need to add. That's your key. We need to add the square of our legs together. Let's do some examples. So right here, if you look directly next to it, right under finding the hypotenuse, okay, I have a right triangle. So this first right triangle, I have my 2 legs right here. I'm going to go ahead and label them A and B. And then I have my C. I don't know the value of C yet. I know that I'm using the Pythagorean theorem. So I'm going to use A squared plus B squared equals C squared. And all I do is I plug these values in. So 5 is my A, so I'm going to have 5 squared, plus my B is 12, so 12 squared equals C. I don't know what C is, so I'm going to leave it C squared. Now I can just go ahead and simplify this. So 5 squared is 25 plus 12 squared is 144 equals, I still don't know what C is, so I'm going to leave it C squared. Now I'm going to add my legs together. So 25 plus 144 is 169. And that equals C squared. Now remember, I'm looking for what C is, not C squared, so I need to cancel out that squared. And the way I do that is I take the square root. If I do it to one side, I have to do it to the other. So this squared gets canceled out, so I have C all by itself. And then the square root of 169, you can use your calculator, is 13. So this side length right here, what I'm looking for, this side length is 13. All right. Now, let's talk about whenever we're missing a leg. So right here, if you look in my example, I have a right triangle. I have my A, which is 4. I do not have a B. I do not have the length of my B. And then my C is 5. So I'm missing the value for this leg. So I'm still going to use my Pythagorean theorem to help me find this. I'm still going to use A squared plus B squared equals C squared. And I'm just going to plug in what I know. or substitute what I know. So right here, my a is 4. So for a squared, I'm going to put 4 squared. Plus b, I don't know what b is, so I'm going to leave it b. I have b squared. Equals c squared. Well, my c is 5, so I'm going to put 5 squared. Then I'm going to simplify. So I have 4 squared, which is 16, plus b squared, because I don't know what b is, equals, and then 5 squared is 25. After this, I am going to subtract my leg from both sides. Okay, that's our key word here. What I mean by subtract is in order for me to get b squared all by itself right here, I need to cancel this 16 out and move it to the other side. Well, since it's positive 16, in order for me to move it to the other side, I need to subtract 16 on both sides. So 16 minus 16 would be 0. 25 minus 16 is 9. So now I'm left with b squared equals 9. Now remember, I'm looking for b by itself, not b squared, so I need to cancel out that squared, and the way I do that is I take the square roots on both sides. Whatever I do to one side, I have to do to the other. The square root of b squared is b, and the square root of 9 is 3, so b is 3 for my right triangle. And then on this one, our keyword is subtract. Now I'm going to move over and do an example of whenever we're missing a leg. So I'm going to do this first triangle right here underneath finding a missing leg. First thing I'm always going to do is I'm going to label my triangle. So I have side A, which is a leg, side B, which is another leg, and then side C, which is my hypotenuse. I'm missing this value right here for B, so I know that that's what I'm going to be solving for. I'm still using my Pythagorean theorem, so I have a squared plus b squared equals c squared. My a is 6, so I'm going to substitute 6 for my a in my Pythagorean theorem and squared, plus b squared. I don't have a value for b, so I'm going to leave it b squared, and that equals c squared. I'm going to substitute 10 for c, so I have 10 squared. Now I'm going to simplify. So 6 squared is 36 plus b squared. I don't know what b is, so I'm going to leave it b squared. And then 10 squared is 100. Now, in order for me to get b by itself, the first thing I need to do is I'm going to have to subtract 36 from both sides in order for me to cancel it out on this side. So I still have b squared over here, and then I have 100 minus 36. 100 minus 36 is 64. But remember, I'm looking for b, not b squared, so I want to get b all by itself. So I need to cancel out this squared right here, and the way I do that is I take the square root. If I do it to one side, I have to do it to the other. So this square root cancels out the square, so I have b all by itself. And then the square root of 64 is 8. So this right here, b is equal to 8. That's the side length of my triangle. And remember, our key word for missing a leg is to subtract. Okay, you will need to finish the rest of the practice problems on this foldable. There's 4 more triangles that you need to finish. When you are done, you are going to close your foldable up. You're going to take that second or that next page 5, which is a blank page. You're going to put glue on the back. You don't need a whole lot of glue, but you're going to put some glue on the back of it. And then you're going to glue it onto that blank page, so now it will stay in your binder.